Okay, this is section 4.7, word problems, which are amazing. You will have, I suppose, a separate handout for that as well. This is the forbidden formula. This will pretty much reliably give you the x value of the vertex. I don't want you to get used to using it because I'm not sure if you're allowed to in the grade 12 course. Not that parabolas necessarily come up, but anyways, it's a way that you can check whether or not you got the vertex. So the B and the A are referring to the B and the A in this formula. So it's just another option for you. Okay, for example 1, it seems to be a pretty straightforward question, so I think I'm just going to say for this one you should really just see your notes, see my notes. For this example, I am gonna go through it just because it is a tricky one. So you might have something like this on your test. Who knows? It's a mystery when I say stuff like that. Who knows what's gonna happen? But for something like this, you will want to make a table. So you'll know when you want to make a table, because I'll start giving you a bunch of information in the question, and it'll have to do with some sort of a situation. So we pretty much have, let's see, something about a parking pass at $20, and 150 students are going to buy parking passes at $20. Let's say they do some studying, and they find out that for every $5 increase in the price, they pretty much expect that 20 fewer students are going to be able to buy the pass. So what is the price of a parking pass that will maximize the revenue? So remember, when we're talking about parabolas, so if this question were just to come up on the exam, like, how would you know it's a parabola question? Because of the word maximize. So we know that when we have a parabola that is opening down, the vertex is a maximum. So it pretty much models the situation, because if you think of this curve as being your price, so as you increase your price, you'll get to a certain point where you'll hit some sort of sweet spot, and then after that, as you continue to increase your price, the number of students who are buying it is going down. So if you think of this as your price, and then this axis as being the number of students, price going up, number of students going down. So that's why we can use a parabola to model that. So here's the table. So they're going to ask us, what is the maximum price, and the price that'll give us the maximum revenue, and then what is that actual dollar amount. So pretty much we got just two variables, pretty much, the price of the pass and how many actually get sold, and then we can keep track of the revenue. So initially they tell us 20 and 150, so when you multiply those together you get 3,000. This is what the pattern looks like. So for every $5 increase, so this is one increase of $5, I'm going to lose 20 students once. So 150 minus 20. So if you were to fill that in, that's 130. This gives you 25. When you multiply those two numbers together, you're gonna get something. I guess I'm gonna have to find out. Awesome. Alright, on the next step, this time we've increased the price twice by $5. So it's a $10 increase, and now you're at $30. so we're going to lose 2 times 20 students, so we're going to have a grand total of 110 students. So I'm doing this just to see what happens to the price, and so we can see that price going up. At a certain point, if you continue doing this, I lost focus. There we go. If you continue doing this, you're going to see the price, it's going to hit a certain spot, and then it's always going to start decreasing after that. From this pattern though, I can get some sort of equation. So on the next step, here's my equation. So for the price of the pass, it's 20 plus 5x, where x is, you know, the number of times I'm increasing the price by $5. That matches up exactly with how many students I'm losing. I'm losing 20 students for every one time that I increase by $5. So these two variables are the same. Once you have that, you can multiply those together. Why can I multiply those together? Well, this is the revenue, and it's equal to the price per ticket times the number of students who buy one. That took a long time to write. Okay, so I actually have these expressions like 20 plus 5x, well, that is the price of a ticket. And 150 minus 20x, well, that is the number of students who are going to buy a ticket. So when I slap these two things together in brackets like this, I'm now going to get a quadratic. Very suspicious. So if you actually go ahead and FOIL it out, you're going to get this beautiful thing. You can try that on your own. When you group your like terms, so when you add up these two x terms, you're going to get finally this quadratic. Okay, now I'm noticing that I've probably done something right, because remember before in my graph when I said we're going to look for that maximum price, we need a parabola that's opening down. I'm seeing in my equation, hey, this is a negative 100x squared, so this parabola will be opening down. So I've probably done something right. So I need to find, you know, what is that maximum revenue. So I'm looking for the x value of the vertex. So if I could find that x value of the vertex, then I can go back and I have these two expressions. I could figure out the price per ticket. I can figure out how many students, because I have those two equations right here. So now you have two options. Well, sorry, you only really have one option. To find that x value of the vertex, we need to know the x-intercepts of this function. So I'm going to do that right away. So probably a good example of a spot where I'm just going to use the quadratic formula. You might have noticed that I actually pre-wrote the quadratic formula. I totally did this scribble thing on purpose. I knew that was going to happen. I'm just trying to emulate your thought process that you might go through on an assignment or a test or whatnot. So I would write that out. Plug it in to the quadratic formula and solve for x. Let's see what we get. I'm starting to get a little tired here. I did not mean to make those scribbles. So A is negative 100, and and C is 3,000. Meant to plug those in, and then 2 times A. And there we go. So gonna get an answer for that, getting this number, which I know kind of looks ugly, but when you do the square root of it, you're actually gonna get, and I encourage you to try it out. I'll show you what you get. This actually ends up being a perfect square, and you get 1,150. over negative 200. So when you get the two values from your calculator, when you plug them in here, so I'm going to do plus 1150 divided by negative 200. I'm going to get x equal negative 4. When I do negative 350 subtract 1150 divided by negative 200, I get 7.5 equals x. So those are just my x-intercepts. Remember that to get the x value of the vertex, you got to do that formula. So we got negative 4 plus 7.5 over 2, which I don't feel like doing in my head. So I get 1.75. Okay, now remember that x was representing how many price increases I'm going to be doing. So I can't do 1.75 price increases, so you're going to round to 2 for this word problem. Once I have that, I'm going to go back over here. If you use this formula, which is just fine, you can very quickly, by plugging in negative b over 2a, here's the work, you can very quickly just confirm that you got 1.75, you get 2. So I'm giving it to you as a way for you to check your work quickly, but I do want you to know how to do it using this method here. So I'm going to go back up here and just going to look at these two formulas. I'm going to remind you over here, this is the price per ticket and this is the number of students who want to buy a ticket. So part A is just asking what is the price of a parking pass that will maximize the revenue. Well, we found out we're doing 2 increases. So my formula for the price was 20 plus 5x. So going to be plugging in x equal 2. Going to be finding out that the price that will maximize the revenue is $30, which we had in the table. If you try 35, you're going to see the value in the table for revenue going down, and that's exactly what they're asking in part B. What's the revenue? Well, just complete accident, we already calculated it over here. So just a reminder, that was the price times the number of students that would buy at 110. So you get 3,300. Just to be really clear, I'm going to use my formula again, so I know we already did it, but just to remind you of where it came from. So this is the quadratic formula that I had before. We found out that x was equal to 2. So we already know that this bracket, the 20 plus 5x we just calculated in part A, we know that that evaluates out to 30. It's the other bracket that we're not sure about. So this is going to evaluate out to 110. So when you do that calculation, you should get 3,300. Alright, I'm just trying to think of other possible things that I could ask you. So I asked you for the price, I asked you for the revenue at that price. I guess the other thing I could ask you is for, the number of tickets sold. So it's very important that you label your brackets. Okay, so we labeled that this one here, this was the number of tickets sold. So when x is equal to 2, we know 110 tickets are sold. Okay, so just a quick recap for this question. Basically, you will, figure out a formula. Usually it's going to be some sort of a price times, number of students or number of things sold, whatever. So you will get 2 separate brackets, and most important thing is that you label what these brackets are. Okay, so clearly label for later, which one is which. So this is the price bracket, this is the number sold bracket, so to speak. Okay guys, well, that's that. I wish you good luck. You can try this tasty soup chicken wrap question or something. If you don't remember what it's about, you can try the homework.